here. And let's figure out how we're going to do this. Let me minimize it. Let me take a screenshot. All right. So might be helpful to put in some of these values. Particularly the zeros. Anytime you see a zero, it's going to give you a big clue as to what kind of a function it is.
Yeah.
This looks familiar all of a sudden. We did this one.
I don't think so. I don't think I have that one written down.
Well, okay. If I plot some points, notice that the x goes up by 1 each time. Okay?
Yeah.
So when x is, let's say, -2, y is 8. When x is -1, y is, -1, y is there. Here, let me erase this one because that's going to confuse us. When x is 0, y is -4.
Okay.
And when x is 1, y is -4. And when x is 2, y is 0. And when x is 3, y is 8. What is the only kind of shape that fits those points?
A parabola.
Exactly. In other words, I cannot draw a straight line through that, so it's not linear.
Yeah.
And it's not exponential. Exponentials look like that, or maybe sometimes like that, but one
Yeah.
or the other. So the only thing that fits all of these points is something like that, a parabola. So
How would I write that function?
well, okay. So first of all, we know that it's quadratic.
Okay.
Now, writing the function. This is actually a big subject because we kind of need to talk about the various formats for quadratics. Okay. The most
Yeah.
popular format is Vertex Format. Do you know what the general format for that is?
Is that y equals mx plus b? Or no?
No, that's for linear.
Oh yeah.
We're talking about quadratics here. So something has to be squared.
Okay.
And the reason it's called vertex format is because h is the x coordinate of the vertex, k is the y coordinate of the vertex.
Mm-hmm.
And you can see that with any parabola, the most important point is going to be that vertex, right?
All right.
So that's kind of what we want to know what it is. Unfortunately, with the table of numbers that they gave us, we cannot immediately figure out what that point is. So vertex format may not be the best format to use. There is
Okay.
another format, which is X-Intercept format. And I gotta believe that they've taught you both of these. Otherwise, they wouldn't be giving you questions like this.
Right.
And it is, they use x minus p times x minus q. Notice that when I multiply those two things together, I'm going to have at least an x squared, right? Same as the previous. So these are both quadratic expressions.
Okay.
not linear. Y equal mx plus b is x to the 1 power only, and it's a straight line. But it's not
Mhm.
this. Now, this probably is the one we want to look at. Why? Because we know that point and that point. Correct?
Yeah.
Okay, so let's fill in as much of this as we can. Y equals, we don't know what A is yet, but we know the rest of it. What's the rest of it?
Okay. Um, I have no idea.
Well, we're looking for where Y is 0. In other
Okay, so
words,
that'd be
the 2 points
-4.
on the parabola that I have circled,
Oh, okay, yeah. So -1 and 2.
you got it. Okay,
Gotcha.
so what does this become when -1 is substituted for P?
-1 is substitute. Uh, oh, so that'd be -1 or
It's X plus 1.
X.
In other
Oh,
words,
yeah, okay, yeah, I
because
get
it
you.
becomes X minus a -1.
So it's +1, yeah, gotcha.
Yeah, okay. And X minus Q, what's the other place where Y is 0?
It'd be 2, so it'd just be X minus 2.
You got it. Okay. So that's most of the formula. Now the only thing we really need to solve for is A.
Okay.
Okay. And we know all kinds of points here. We know that when X is 0, Y is -4.
Okay.
So let's put Y -4. That's going to be equal to A times, I said when X is 0, 0 plus 1 times 0 minus 2. You see what I've done?
Yeah.
Okay.
Got it.
Well, that is -2A. So going up to the top here, I now have -4 equals -2A. A has to equal 2.
All right.
Now we have the formula. It's Y equals, remember this is the standard general format we're going to use. Only we know what A is. A is 2. We know what P is, -1. And we know what Q is. So that is our formula for this problem. That's the function. In other
Okay.
words,
Yeah.
for
Gotcha.
right here, that's what you want to put.
Okay, cool.
Okay. Now, they didn't specify a format. They just said write the function. So this function is every bit as valid as any function you could have. Now, the fact of the matter is that we actually could have figured out this vertex over here, and we could have put it in vertex format. And
Mm-hmm.
it would have looked a little different than this, but it would have been the same function.
Yeah.
Okay? All right, so let me erase all this, and let's do the next one. So first of all, let me put in our values. -3, 8, -2, 4, -1, 2, 0, 1, and 1.5. Let's graph those, just see what we're looking at. So there's a point right there. That's our first point when X is -3. X is -2. There's our second point. When X is -1, there's our third point. What's this starting to look like?
Uh, it's probably linear, I would say.
Yeah, it looks like a straight line so far, unless I've really messed up. It could be a parabola, but we'll find out. When x is 0, y is 1. Now it's starting to look like there's maybe a little more curvature on it. When x is 1, y is 0.5.
Okay.
Now, I would say that's probably
Oh,
linear.
you exponential. Oh,
No,
no?
only because they didn't give us more points. If it was
Okay.
exponential, they would have probably given us more points so that we could have seen a curvature like that.
Okay.
Okay, so I'm thinking this is linear, and that's where we're going to begin. We're going to call
Okay.
it linear, and then we're going to try to come up with an equation. What's the general format for linear equations?
Would that be y equals mx plus b or no?
It is. That
Cool.
is the first one you're taught. There's a couple of these also, but that one will do. Now, what does M mean?
I think isn't that like what affects the
That's the slope.
yeah, that's the slope. That's what I was gonna say. I just didn't know the word for it.
Slope is, believe it or not, one of the most important principles in all of mathematics. You're going to talk about slope in Algebra 1, Algebra 2, geometry, pre-calc, trigonometry, calculus 1, calculus 2, calculus 3. It's unbelievable how important slope is. So remember what M is. What is B?
Okay. Doesn't that just add to like isn't that like transformation or something like that?
That is the Y-intercept.
Oh, it is? Okay.
Huh? So I'm going to call that the Y-intercept, and I'm going to call that slope.
Okay.
And that's pretty important because we have a Y-intercept on this thing. So I immediately know what B is. First of all, what is it? Remember, your Y-intercept comes when X is 0. Your X-intercept comes when Y is 0.
So it would be 1. B would be 1, I think.
When
Right? Or no?
X is 0. Oh, let's see. Sorry. Yes. Excuse me. I got on the wrong table for a moment. Yes, when X is 0, Y is 1. So now we
Okay.
know this much. We know Y equals some slope that we haven't calculated yet, plus 1.
All right.
Now, if we can solve for M, we'll have the equation. Well,
Okay.
slope, what is the verbal definition for slope? And this is probably the
Uh,
most important thing you want to remember.
rise over run.
Yes, because if you know that, if you know that it's rise over run, you can figure out all the complicated math. In other words, the rise, we'll talk about it as the change in the y, and the run we'll say is the change in the x. Well,
Okay.
the change in the y is y sub 2 minus y sub 1. The change in, excuse me, this, I need an M there, slope, and that is equal to that. In other words, this is what they want you to memorize. Problem is, there's a lot of stuff there, and people have a hard time memorizing it. But if you can
Yeah.
just remember rise over run, you can always get to this formula.
Okay, cool.
Now, we need 2 points. That's all you need. If you have a linear equation, then you just need 2 points to figure out slope. Well, let's pick
Um,
any 2 points. Let's pick 2 points that have whole numbers. How about these 2 points? Right there.
okay.
Now, what's the slope going to be? Y sub 2 is,
Um, so yeah, so it'd be just like -1 or something like that.
okay, that's the change. Yes, that's 1 minus 2. And what is the run?
Change. +1
Very
or
good.
just 1?
No, you're right. Just 1.
Okay.
Which means our slope is -1.
Okay.
Okay, that's everything.
So,
Now we have the whole equation.
oh,
It's y equal negative. I don't have to write the 1. In other words, there's a lot of places where you don't have to write the 1. And that is our presumed equation.
negative x plus 1.
Uh-huh.
Okay.
Now, before we,
Oh, yeah.
if my life depended on it, I would not give that answer. And the reason why is, oops, sorry. The reason why is that that thing looks like it could be half of a parabola to me. So did they just not give us enough points, or what's the deal? Well, if this is the right equation, then every single point they gave us has to fit that equation.
All right.
Well, how about this point right here? Does that fit that equation? Here's the equation we came up with. Well, 8
No.
equals, no, it doesn't. It's equal to minus minus 3, which is 3 plus 1. This thing is not linear.
Okay.
This thing is quadratic. So all of our reasoning is incorrect. We now see that it doesn't fit linear, and there's only a couple of other choices. It could be exponential or quadratic. You kind of have to pick one. I suppose it could be either one. In other words, quadratic's going to look like that. Exponential is going to look like that. So
Yeah.
maybe it's
I'd
exponential.
say exponential, yeah.
Because they didn't draw the whole parabola. So let's assume exponential. Okay. Just put in a couple of points here. Now I'm going to do the whole thing. I shouldn't have erased it. Okay. So what is the general format for exponential? This is actually good because it forces us to go over all of these general formats. And these general formats you really need to memorize. Those are the key to doing all of these problems, is knowing
Okay.
what the general format is. Well, if we assume exponential, general format tends to look like this. A times b to the x. That's exponential.
Okay.
Now, we already saw that the graph looked a little bit like that, right?
Yeah.
And we're assuming it's exponential. Now, the difference between exponential looking like this or like this is whether b is greater than or less than 1.
1. Yeah.
It's going to look like this if b is greater than 1. It's going to look like this if b is less than 1.
All
So
right.
we automatically assume that b is probably a number between 0 and 1. Okay.
Okay.
Now, here's the other really clever trick you can use with exponentials is when x is 0, what is y?
X is 0. 1.
Okay. Now tell me, what's that equal to?
17. 0 is 1.
What's that equal to?
Is that also 1? Or is that negative 1?
Everything is 1.
Okay.
Anytime you take any number to the 0th power, you get 1. Okay?
Okay.
And that's helpful here because we know that when x is 0, y is 1. So I can fill in 1 for y. I don't care what this is. I know that b to the 0th power is 1.
All right.
That tells us what A is. A has to be 1.
Oh.
Now we have another piece to that equation. It's 1 times b to the x. Okay, we don't have to write the 1, so I can erase that part of it. Now all I could do is solve for b, and I'm home. Well,
Okay, I gotcha.
let's pick another value for x. How about 1?
So it's 1/2.
Okay, so y is 1/2 equals b to the 1 power. That tells us what b is.
Oh.
B is
So.
1/2.
All right. Cool.
So now the equation has to be y equals 1/2 to the x. When you come up with your final equation, you want x's and y's. You don't want any a's or b's. In other words,
Okay.
you use the data to solve for a and b, but your final equation, you go back to the x and the y, and you substitute whatever a you solved for and whatever b you solved for.
Okay.
Okay, so I'm going to call this exponential, but once again, I would not bet my life on it until I check another point. Because first time through, it looked linear, and we were wrong. In other words, when I checked another point, it proved that we were wrong. Well,
Okay.
how about this? Let's check this point right there. When x is -3, is y 8? Well, I'll put y be 8. Is that equal to 1/2 to the -3 power? And it is. 1/2 to the -3 power is the same as 1 over 1/2 to the 3rd power. 1/2 to the 3rd power is 1/8. So it's 1 over 1/8, and that is equal to 8. But that color on black sure is more visible than it is on gray, huh? Yeah, I'd be better off if I could somehow have a total black screen with this color. But anyway, I solved for the equation not using that point. Never did I use that point. I used 0 and I used 1. So when I check to see if my equation is correct, I don't want to use those 2 points, either one of them, that I used in coming up with the equation. I want to use a different point, as far away as possible. And that's why I used -3, 8.
Okay, cool.
Okay. All right, that's a good place to stop. These are pretty good questions. It forces you to really know your general formats. You can see that. There's
Yeah.
a couple of general formats for linear. There's a couple of general formats for quadratic, and there's one general format for exponential. But by the time you've done these 4 problems here, you're going to know all about all 5 formats and
That's awesome.
how to solve for the equation.
Cool.
So
I gotcha.
we're doing Tuesday and Thursday at 6 every week.
Yeah.
Okay, I will talk to you. Have a good weekend, and I will talk to you next Tuesday at 6. Sully?
Absolutely. Thank you, man.
You're welcome. Bye-bye.